It's no juju. I know. I just want better job than something. I might get stuck there. Hello. How's it going? A Tula FPS. Mm. will cut your fucking head off if you enter this house. I'll be right back. Hey guys, how's it going? Came up with this theory a while ago. Not a long ago. Universe is frozen. Pretty interesting stuff. I wanted to add to that, log it somewhere in the years. That the possible that the internet connection is way too slow. Yeah, just cover up my video. There you go. And now the video is finished. Alright, there it is. Anyway, the universe is a black holes. Actually, I wanted to include in that this is a compressed cavern with large amounts of water kind of going over the top. That's due to the membrane that's being formed by our sun, which we call the heliosphere, as a bubble. Anyway, this is a compressed cavern, so what does that mean for science? Well, it might be the reason our planets are round. Is the pressure coming from the top and from the bottom. And pressure from the sides comes from the planets that are creating force upon each other. It still doesn't explain Pluto, which is pretty interesting to note. However, Jupiter is pretty large, and somebody once said that it has enough heat to actually be a sun. So the shape of Pluto, the size of Pluto, might be directly relative to the size of Jupiter. we don't have a Saturn-type planet between our sun and our planet. Um, I can't explain why yet. But thus far, I do have solid proof that the reason the planets are round is because of the pressure the pressure that is being forced upon each individual sphere that's in orbit around our sun. Um, Somebody once said that Saturn was a black hole, by the way. And somebody's trying to get me to say that. And so I don't have that information either since it's a gas. And there isn't enough heat to actually vaporize water out there and create gas. During the formation, that it was extreme amounts of heat which would have created a gas planet out of a black hole. I'm still questioning this thing because it really is a gas planet. Black holes really do have this tendency to attach themselves to different solar systems. It's kind of this attraction that they have. It's normal, but I'm still iffy about Saturn being a black hole. However, it might have been on the outer rim of our solar system and might have collected water from the heliosphere and from termination shock, just some of the water droplets, and might have created those rings. I'm not sure about that either, but it seems to be pretty accurate. Yeah, heat and convection and temperature of the sun. Something that scientists sooner or later, once you do your homework and realize that I'm right, you're going to have quite a field day with the thermal convection and the thermal and heat and cold exchange physics between our solar system, the sun, and our cavern. It's going to be quite a party for you guys. It should be really interesting to see what you guys come up with once you start doing that. What else? There should probably be a string coming from the sun. Because once again, a string coming from the point of our cavern that's at the closest point to our sun. As the sun's rotating, and it might have an effect on the heliosphere there, making it swirl. And since that's a fluid membrane, it should retain. It'll be warming this area, and hopefully pulling that up and creating these fantastic little black hole-looking threads from our solar system into space. Oh, Oort cloud. That's not a cloud. That's just sedimentation. It's not a gas cloud. Make shield us from. There was a scientist on Astronomy Magazine here on Facebook, on the Astronomy Magazine. They're pretty good. They're pretty good. They're pretty good with their scientific observations. Who was stating that a gamma burst from a distant galaxy might whoop our butts. Probably it can. I'm not saying that it's impossible. It would have to be extremely strong and nearly melt the ice that's near the heliosphere, the heliocause. We've actually seen solar systems that look like they've got hexagonal shapes into it from Lord knows what the hell open fired on that, and melted the section of the metallic sedimentation from their cloud cover. The Oort cloud is metal. We all know that, and in that being metal, it provides a shield against that type of activity. Now, there is something else I also wanted to include here. Is there is a fantastic part of physics just dying to pop its head into this, which is metallized hydrogen. Now, we're talking about here, or I'm talking about the entire scope of outer space is frozen, is a block of ice. The pressure from outer space is enormous from in something like that. Everything is applying pressure. Now, keep in mind, our sun is gravitational and it's affecting and effecting. So, let's say there's stones out there, there's meteors, there's whatnot, and it's an attractant. Now, these particular stellar objects are launched in ice at the moment, and that has generated the process of fusion. So what's going on is that's applying enormous amounts of pressure in their attraction to the sun, and whatever reason we're not navigating towards it. Probably somebody else, some other metallic force is holding us in place, keeping us from doing that. There are enormous amounts of pressure on the hydrogen masses and hydrogen, helium, and whatever frozen gases are out there between us and anything else. So the hydrogen is frozen, and then it's got pressure being applied to it. So the interest in physics as to what in God's name is going on there should be peaking right about now. And once again, you have the metal and you have the Oort cloud, and then what are the chances that there are fields out there of metallized hydrogen, and what would be the consequences of something like that? Um, Definitely worth a look. It might be able to provide solutions as to being able to synthesize metallized hydrogen here on Earth in a frozen medium, but that's all theoretical once more. Um, I've done much homework because I've been getting our butts kicked down here. Anybody want a cup of coffee? Come on. So, for those of you who aren't aware of what the flag I'm talking about, this is my other Facebook page. Guess what I did? Just the old habit of what I usually do, which is I keep getting my butt booty, douchebag, which I'm not. Anyway, the universe is a giant block of ice. I came up with I ended up making the discovery. You came up with that. I actually fabricated it. Not really. I went ahead and I came up with the discovery after studying the radiation shock as well as the heliosphere, which is listed on my webpage. I haven't put on here. Spent a while trying to keep that separated. Anyway, there is a fluid membrane on the outside of our solar system. NASA's gone ahead and locked it based on Voyager's data and telemetry. Voyager 1 and 2. Cassini hasn't really seen that much of it, so not quite sure what's going on with that. But when Voyager was approaching the heliosphere, it, there's a druzy type wall of water droplets parallel, a perpendicular one, before actually going to the denser version of our helio sheath, which is reflecting some sunlight. So what ended up happening is when Voyager actually reached this point on the heliosphere, when it reached this condensation, it was taking a reading of approximately 40,000 degrees Fahrenheit. Now, what was going on there is it's our sun that was causing that. That's an actual Mach mirror. Now, during that time, plasma density, as reported by Voyager, was also increasing. So Voyager was slowing down tremendously from 94 astronomical units, I believe it was, and the other Voyager, when it reached that same position, was slowing down from 84 astronomical units. Anyway, as it crossed through this particular druzy and plasma density increase is reported there on Wikipedia about Voyager. Plasma density is literally liquid. It's hydrogen, it's water. Um, Once it reached the second phase of our heliosphere, which was just closer to the ice that the sun is melting on the inner cavern of our solar system. Voyager took readings of thermal temperatures at 80,000 degrees Fahrenheit. It was pretty interesting stuff there. So Voyager went ahead and went for a swim. Voyager 1 and 2. And when Voyager 1 crossed through, they said that the Voyager was going to go to all these places and was going to navigate the galaxy, and its instrumentation would work for 200,000 years. Voyager is not going anywhere. It's not doing squat. It's a sitting duck right now. It's taking readings, which is really nice, and it's watching our solar system swim away at 3.2 astronomical units. Now, the reason that's happening is because, once again, it went through this heliosphere, the heliosheath, and then dropped itself in a block of ice that right in the middle of the galaxy. It's just sitting there, not really able to do squat. It can still send images, depending on I'm curious as to whether or not the temperatures are too low for it to function at this point. But Voyager 2 encountered the same thing. Now, keep in mind, now let's go ahead and let's grab the big fact here. What's the big fact going on? Astronomical units. Voyager 2 is traveling at 84 astronomical units prior to reaching this fabricated fantasy of a bubble, which is the heliosheath, and slowed down to 3.2 astronomical units, taking the similar readings as Voyager 1, and remains at 3.2 astronomical units to this day, from 84 and 90-something odd astronomical units they're traveling at. Now, you ever get that feeling like that kind of a slowdown has nothing to do with propulsion? All right, so an enormous slowdown. So they actually at least were able to take a measurement of how fast our solar system is traveling, which is 0.2 to 3.4 astronomical units, which is the final velocity between Voyager 1 and Voyager 2. At the time they crossed the termination shock of our solar system. So with that being said, furthermore, my favorite subject matter in the whole freaking universe is the black holes. The little spinning disk. It's like a record player. Really cute little guys. Well, what's going on with particular those guys? It's not a gravitational force at all. That's not a gravimetric field. That's not any of that. It's something in the middle there that's generating immense amounts of heat. And what's happening is the thermal values of the object that's spinning in the middle in question is actually melting the ice surrounding this particular black holes and are generating a lens. So it's basically this tiny little doohickey here. It just goes like a freaking maniac, and it's creating this fantastically enormous lens. I have no idea what kind of measurements you could take. However, black holes will promise to be the only means by which to look into deep space at the moment. That's right, guys. You have an enormous telescope. You have a gigantic whole telescope sitting there with enormous power that looks to make out with our solar system every once in a while. So all you have to do is find the rims of these spinning, theoretical, Hawking rays into the smell of its star apparently. And just look through that, and you can actually get a better view of the universe. Speaking of a better view of the universe, our actual cavern here is not static. That's not air going out there. You already have scientific evidence and scientific publications of there's a bubble around our solar system. So what does that mean? Well, actually, anything you see through a telescope is not going to be exactly what's on the other side of that bubble, because it's reflecting light, it's lensing, it's changing shape, and it's doing all sorts of horrible crap to your interstellar observations. It means that the universe is neither expanding or contracting. It's a solar system. And probably what some of the models that I've seen of of our universe and it being contracting, and it's got these two little spheres. There's a pretty good chance those little buddies are black holes sitting there playing bingo with our solar system. So yeah, that'll happen. It can be harmful. I have no idea, but yeah. Anyway, so the system is the actual cave in which we look through in order to observe outer space is changing shape on a constant basis. One of the only ways we have right now of getting an exact reading as to where the flock any of these stellar objects are is through sound. You can sit there, you can fire anything from a Weber, you can fire somebody's thermal butt into that helio sheath, and it's not going to give you a clearer reading of what's on the other side, because it's the entire wall of our solar system is misshapen. It's not static, it's not constant, it's not going to happen, Captain. So you have to do your best. You're still obviously getting some images and pretty clear ones, actually. So it's not entirely inaccurate, but the sound sources for those particular observations are extremely vital to your scientific research as astrophysicists, as opposed to just visual contacts. We've kind of been working on that and didn't realize it was that important because we thought it was dark energy. Because the point of light from the sound source is over here, while the actual object is over here going, and it's the same little dude. So what does that mean? It means you have to actually work a lot. You have to work for at least 12 hours, man. You can't just go, ooh, look, I found it, dude. And in that note, I have to turn this off because I'm getting this premonition that we are about to get struck by no fucking lightning. So yeah, big time. Anyway, how solar systems are formed, and two rocks are in outer space, and they clash with magnetism as well as ferromagnetic fields go ahead and fluctuate, so it pushes back out. Polarities change. The polarity flux is a constant polarity flux as these rocks are broken up and induce incredible amounts of pressure that probably contains sort of ignitable materials or contain hydrogen, and we come back out, come back in, and come back out, and come back in. Since it's a great deal amount of energy that's released when they're in hydrogen, it means that it doesn't it generates a direct gas. Some of the gases in the universe stuff like gas here on Earth, such as helium and argon and whatnot, are probably frozen materials in the universe. So it becomes a gas immediately in these particular caverns where these two objects collide and form a solar system. They create a gas cloud of their own products and pull in other products that were lodged in the ice in the surrounding regions and form the solar system. And that's how you get a lot of these beautiful nebulous formations on telescope observations, and hopefully we have the right position on them. If we don't, well, we get to keep going, we get to keep working, but at least we got something going on there. Anyway, have fun. I'm Beatriz Rodriguez, and I discovered that the universe is a frozen beehive. Ah! There's no wrong fucking edit my audience. No, not me. No. It's not translation. No, edit. What? No. Public. It's public. Yeah, I don't know. Not really very well. Um, it's a month I got to that. Doing my talking backwards. That the upper that the reason as well. Still not my video. There you go. And the video is there. Anyway, actually, I was including the compressed, yeah. Anyway, this is the compressed cavern, so what does that mean for it might be confusing our planning and pressure from the side comes from the planet. Oh, that's not so. And so the pressure being, the pressure is, going to come from, people here that, in orbit around us. Um, somebody once said that Saturn, gas planet, I'm still interested in gas planet. Black holes really do have this to attach themselves to the crystal, and it's attraction. my teacher. Now, keep in mind, our sun is gravitational and affecting and defecting. So, this paper is found up there in years and whatnot, and contracted. I mean, people are still on there for lunch the next morning, and that is generating the process. So what's going on is that's applying enormous amounts of pressure in their sections to come. And whatever reason, we're not navigating from this, probably somebody else, some other, college. Now, Terrence. Specific as to what you guys think is going on there to be thinking right about now. And once again, you have the metal and the report cloud, and what are the chances that there are fields out there of metal and type that would be consequences of something like that? Definitely. It might be able to provide solutions and being able to synthesize like types here on Earth and frozen medium. But that's all theoretical once more. Um, yeah, I'm doing right. For those of you who aren't aware of what the song is talking about, you might have to get the idea that the old habit of working with the anyway, you have to do I come up with this, I ended up making this discovery. Yeah, I actually have it to I ran in and I came up with the discovery studying the communication tropical experiences listed on my webpage. Have it put on here. Anyway, there is a fluid membrane on the outside of our phone. Now, for some reason, lots of things from Voyager's data, one state, Voyager 1 and it really hasn't really seen that much of it. Not quite sure what it's but when Voyager was, yeah, really, there's a series of wall water droplets parallel to the particular one before actually going to the depth of the our community, which is reflecting some sunlight. So what ends up is when Voyager actually reached this point on the field, the heliosphere, when we reached this condensation, it was taking a region of approximately 40,000 degrees Fahrenheit. Now, what was going on there is that's actual Mach years. Now, during that time, plasma density as reported by Voyager was also increasing, so Voyager was slowing down tremendously from 94 astronomical units, I believe was the other Voyager, and it reached that same distance slowing down from 84 astronomical units. Anyway, as it crosses through this particular region and plasma density increases before down to about Voyager, plasma density is literally liquid. It's hydrogen, water. Once it reached the second phase of our heliosphere, closer to ice, which is frozen melting on average, where this is reading of thermal temperatures at 80,000 degrees Fahrenheit. So it's pretty interesting stuff here. So where's your one again with George Wind? Where's your one answer? And when Voyager 1, Ross, this is a Voyager going to go to all these places and he's going to navigate the galaxy and the work for 200,000 years. Where is this going anywhere? And like, it's like sitting up right now. It's taking readings on as it's watching it. So it's the way at 3.2 astronomical. Now, the reason that's happening is because, again, it went through this heliosphere, the heliosphere, and then it dropped itself in a block of ice that right in the middle of the galaxy. And it's just sitting here, not really looking like you can still send images, depending on the time period as to whether or not the temperatures are too low for functions. Um, Voyager 2 encounters the same thing. Now, mine, let's go ahead and let's grab the big fat. What's the big fat lineup? Voyager 2 was traveling at 84 astronomical units prior to reaching the gravity intensity of a double community. And slowed down to 3.2 astronomical units, taking similar readings as Voyager 1. And remains at 3.2 astronomical units to this day, from 84 and 90 something like the years they're traveling. Now, I don't. I know the last thing between Voyager 1 and Voyager 2. At the time, they crossed the communication chart of our solar system. With that being said, more just a black hole. Really think about it. Well, someone was thinking of work it off. The current government feels that something earlier what's happening is the thermal balance of the object that's spinning around what is actually built in the ice surrounding the particular black hole and are generating the light. So it's basically this tiny little duty here. It just goes like a freaking maniac and you have to see the one um, and we only hear what kind of language it is. However, black holes will promise to be the only looking space. That's right, guys. When you learn telescope, you have a gigantic whole telescope sitting there with the enormous power that's left to make out with that telescope. So all you have to do is find the rings possibly reasonably um, and just look through that and you can actually get the um, speaking of a better view of the universe, our actual cavern here is not static, it's not here for now. There is no scientific evidence and scientific publications of there's a bubble around our solar system. What does that mean? Well, actually, anything you can see, a telescope is not going to be exactly what's on the other side of that bubble. It's going to be looking light, it's going to be and it's doing all sorts of horrible crap here in solar observations. Means that the universe is there, expanding or contracting solar and probably with this, some of the models that I've seen of our universe and is impacting and it's getting two little spheres. There's a pretty good chance those little buddies when you know what's on our solar system. So yeah, that'll happen. Um, it can be but, anyway, So, the system is the actual we look through in order to observe outer space is infinite constant. One of the only ways we know how just being as the very first watch any of these stone objects are in the house. You can sit there, you can fire anything from a beaver, you can fire a nuclear external what into that helium. And that's going to give you a clearer reading of what's on the other side from the entire wall of our solar system is bigger. No, don't shoot that. It's not constant. Don't shoot that. I'm not kidding. So you have to do your best. You're still obviously getting some images and pretty clearly, actually. So it's not entirely inaccurate, but the sound sources for those particular observations are extremely vital to your scientific research about the primitive, as opposed to just visual contact. Realize it is not important in the story. Since the point of light from one people, the sound person over here will actual objects in the air going and it's the same over there. So what does that mean? When you get this question, you know, like, look at that! And that helps, I guess, kind of off from getting to from listening to that's my most funny thing. So yeah, anyway, yeah, how do you want to rock for the next thing, very big class, nice people with no one so it's really field, so I can fluctuate the pushing back out, polarity, polarity watch, and something polarity watch, and these watches broken up, and it is incredible amounts of pressure, and information things are right now, material, but come back out, come back in, come back out, come back in. The great deal of energy of doing when there are tides of energy that doesn't create food in ice, particular rocks collide, actually the submarine goes to generation direct gas, which is in the universe. It would gas, surface gas here on Earth, particularly in argon and whatnot, and certain materials in the universe. So it becomes a gas immediately traveling through these two objects that collide and form a solar system that they out of their own products and products that was launched in the iron moves around the region and formed solar systems and that down the formation. And telescope observations is something like this one. You know, well, you don't get working, but at least there's something going on. Anyway, I'm Jason Rodriguez, and I'm still in and water down color of the country. That was Oh, there's something you don't see every day. It is. Sure, dude.
The giant Pacific octopus is a crafty predator. Using camouflage and the element of surprise, it can snatch anything within reach of its long tentacles, including small sharks. Party fans. That's awesome. Well done, sweetie. Before NASA's Artemis astronauts go to the moon, the small space
I'm watching a video of you washing your gun.
Oh my goodness. Is that nice? Is that nice in there?
Shave the dog.
You're so cute.
Oh yeah. Oh yeah. Oh yeah. Ah, boring. That's our bell.